Welcome back. In the previous video, we have gone through the different components of a solar PV system. Now, let's go through the different types of solar power plants. And we are going to discuss almost 5 types of solar power plants. The first one is standalone PV system. Second one is grid tie central power system. Third one is grid interactive PV system. Fourth one is grid fallback type PV system. And the fifth one is hybrid solar PV system. Now let's go through the standalone PV system first. So what is a standalone PV system, or otherwise called as off-grid solar power station? So in a standalone system, the solar module produces electrical energy which is utilized to charge a storage battery, and this battery delivers electricity to the connected load. It is not desirable to overcharge or undercharge a lead acid battery. Both overcharging and undercharging can badly damage the battery system. So to avoid these both situations, a charge controller is required to be attached with the system to maintain flow of current to and fro the batteries. So a standalone systems are normally small systems with less than 1 kilowatt generation capacity. As you can see in the diagram itself, we have a solar modules from which we'll get the DC power, and the DC power is sent to the charge controller initially. This MPPT charge controller is a device which we have already seen. It performs many things. Like the first thing it will do is it will not overcharge the batteries, or it will not undercharge the batteries, and then it will connect the battery to the load. It will connect the PV source to the load, right? So these are all different purposes or the functions of a charge controller. So once we feed the charge controller with the DC current, that will be used to charge the batteries, and automatically it will again supply it to the low voltage DC supply equipments like laptops and lamps in the home. If there are any AC equipments, then an inverter will be utilized for converting the DC stored in the battery bank into AC and supply it to the TVs, refrigerators, air conditioners, washing machines, etc. It is how the off-grid solar power station works out. So the next one is grid tie central power station system. So in this one, apart from supplying to the home, whatever is the excess we have generated, that will be sent to the utility grid through a meter called net meter, which you have already seen it. So the consumers can generate the electricity by their own plant and can send the surplus to the electricity utility company through grid connected to their plant. So in a grid tie solar power system, consumers consume electricity produced by solar captive power plants during the day, and also exports surplus amount of electricity to the grid. But at night, when solar plant does not produce any energy, they import the electrical energy from the grid for consumption. So the main drawback of this system is that whenever there is a power cut in the grid, the solar module should be disconnected from the system. Otherwise, if there during a daytime you have an excess of energy, you are feeding it into the utility grid. So during that time, when you are feeding, if there is a power cut in the utility grid, then the energy will not be sent to the grid and energy will be wasted. So this is the only drawback, because at that time you cannot store the energy in a battery. That is the only drawback here. Apart from that, it's a very good system. There are two types of grid tie central power stations. The one is grid tie system with single macro inverter. Second one is grid tie power station with multiple micro inverters, which we have already discussed in the inverter section. Again we are discussing it. So from a complete solar panels, whatever is the DC energy produced, we will give it to a grid tie inverter, which is a single central macro inverter. And from that inverter, DC will be converted, all the DC produced by the solar panel will be converted into AC, and that will be supplied to home, and whatever is the leftover energy and whatever is the excess energy will be supplied to the grid through a meter called net meter or a grid tie meter. Right. So it is about the first one, that is a grid tie solar power plant with a macro central inverter. The only drawback is reliability. So if there is a problem with problem in the inverter, then complete home should be in darkness. It is the only drawback in this system, that the reliability is less. Right. Next one is grid tie solar power plant with multiple micro inverters. As I told you, it's a string inverters. Right. How we will do? For every string we will use a inverter, and by adding the power outputs of all the inverters, we will get the complete power, and that complete power will be again sent to our home, and the surplus power will be sent to the grid through grid tie meter or utility meter or net meter. This is it. So in the previous case, in the first model, a low voltage DC of the solar panel is first converted to AC voltage, then it is transformed to high voltage by transformation action in the inverter itself. But in this case, individual AC output voltage of micro inverters are added together to produce high AC voltage. It is the difference between the first macro inverter and the multiple micro inverters. Right. And the third system is grid interactive PV system. It is nothing but grid tie solar power plant with power backup. In the previous case, we didn't have used any backup. Whenever there is a power cut in the utility, when we have an excess power with us and there is a power cut in the utility grid, we cannot feed the energy into the grid, and complete energy which is produced will be wasted because there is no battery bank to store that energy. But in this case, for avoiding the discontinuity of the supply during the power cut period, one battery bank of sufficient capacity will be connected with the system as power backup. Right. So this is a combination of grid tie solar power generation unit and a storage battery bank. I can see the diagram over here. So whenever you have the excess energy, for example, sunlight will fall on the solar panel will generate the DC electricity which will be fed to the charge controller, and charge controller will store the energy into the battery bank. So from the battery bank you will take the energy through the inverter and you will use it to your home, and whatever is the excess you will send it to the power grid, utility grid. So when there is a power cut in the grid, then what you will do, you will store that energy into the battery bank. You will store the excess energy into the battery bank here. Previously there is no provision of a battery bank, so the energy will be wasted if the utility grid is on power cut when you are feeding the energy to it. Right. So whenever during the night time when you don't have any energy, then from the electrical utility grid you can take the energy. It is how the system will work in a grid interactive type solar power plant. Third one is grid fallback type PV system. In this grid fallback type PV system, it is similar to grid interactive solar power plant, but the only thing is you will use the entire electricity generated by yourself. You are not going to pay, or you are not going to sell the electricity which is produced from you to the utility grid. So grid fallback is more reliable and stable system, mainly used for electrifying the small households. Here solar modules charge a battery bank which in turn supplies distribution boards through an inverter. When the batteries are discharged to a pre-specified level, the system automatically switches back to the grid power supply. Right. Whenever the batteries are drained, automatically your system will get connected to the to the grid again until the batteries are charged by the solar power plant. The solar modules then recharge the batteries, and after the batteries are being charged up to pre-specified level again, the system switches back to the solar power. So we do not sell any electricity back to the electricity utility companies through this system. All the power that we have produced is utilized for ourselves only. You can see it here. So once the solar panel produces the power, it feeds the batteries, and from the inverter through there will be a controller, and then inverter converts the DC into AC, and that AC will be sent to the distributor. There will be a central controller, that is not a charge controller, it is an intelligent controller, and that one, through the controller the power will go to your houses through distribution panel. So whenever the battery first solar panel charges the batteries. So during the night time, what happens, the batteries will be discharged, or maybe during the morning time you have completely used up all your batteries. Then what the controller will do, it will disconnect the batteries from the inverter and the home, and it will take the energy from the grid and send it to the distribution panel, and then to the home appliances. In this while, the solar panel again charges the batteries. Once the batteries are again fully charged, then controller will cut the grid connectivity, and it will restore the energy from the battery bank. It is how the system will work out. Right. So in this way, we are utilizing the electricity which we have produced completely without giving it to the utility grid. The last type is a hybrid solar PV system. So solar hybrid power systems are hybrid power systems that combine solar power from a photovoltaic system with another power generation sources like wind and diesel generator. So there will be a regulation and conversion unit where the energy will be taken by, whenever there is a sun, it will take the energy from the PV modules. Whenever there is a wind, it will take the energy from the wind turbine, and whatever it may be from the diesel generator, it will continuously take the energy whenever there is a shortage of energy with the wind and solar. That is, during the night time, diesel generator will switch on. During the no wind time, diesel generator will switch on again. So these three will work in a scheduled way to supply the energy to the load. And in this case, we have a battery backup also for the when there is we have a battery backup to save the energy also. So once the batteries are charged, and will supply the energy AC or DC through the home. It is how the hybrid solar PV system works out. And coming to the last thing, small systems for consumer applications. Here we have to discuss 5 different applications of solar plants. One is a solar street light, second one is a solar LED lamps, third one is solar water pumps, fourth one is solar cars, and fifth one is building integrated photovoltaic units. Now let's talk about them individually. Solar lamps or solar street lights. So what is this? Solar powered street light works on the principle of solar cell or PV cells to absorb the solar energy in the daytime. The PV cells convert the solar energy into electrical energy during the daytime. The converted energy is stored in a battery, and the street light and the solar street light uses the solar energy during the night time. So whatever is the energy, whenever there is a solar energy, the solar panel generates the energy, and the generated energy will be stored in the battery banks. At the night time, the lamp start automatically, and it uses the electrical energy which is stored in the battery. It is how the solar street lights will work out. LED lamps. So from a solar panel, we'll take, for example, we'll take the energy and feed it to the charge controller through the battery bank, and from the battery bank the LED lights will take the energy in our homes, like garden lights and all these things, all the LED lamps. It is how the solar LED lamps will function. Third one is solar water pumps. How a solar water pumping system will work. In our normal water pumping system, we add the solar to it. Here we can use either AC motor or DC motor. In this example, I am using an AC motor. If you wanted to use a DC motor, means use an inverter. That's it. Apart from that, everything will be same. So water will be there at some depth into the ground. So in order to pump the water to the storage tank, you require a pump and a motor set, right? So the motor have to be supplied by a solar energy, right? If it is a DC motor, we can give the DC supply straight away by means of a MPPT controller. If it is a AC motor, before the motor and the MPPT controller, we will place an inverter. That's it. So whenever sunlight falls on the solar panel will produce the DC electricity, and this DC electricity will be used to drive the DC motor, and in turn it will drive the pump to pump the water from ground level into the storage tank. It is how the solar water pumping system will work out. Now let us see about a AC motor. So we have the sun. When sunlight falls on the solar panel, electricity will be generated, which will be fed to the charge controller and then to the batteries. From the batteries we will use the inverter. An inverter converts the DC into AC and it will be fed to a AC motor, and this motor will run a submersible pump, and this pump action starts and moves water to the overhead tank, and it will be used for the irrigation purposes. So there are two water pumping applications. Now this example is used in the irrigation purpose. It is in the agricultural water pump sets, solar water pump sets, and this is a pump set which is used in our home water pump set, right? The next application is solar car. A solar car is an electrical vehicle powered completely or significantly by a solar energy. Solar car depends on PV cells to convert sunlight into electricity to drive the electrical motors. The electrical energy thus formed is being fed to the batteries and then get charged and is used to run the motor. The shaft of the motor is connected to the rear wheel of the vehicle. It is how it will be working on. So solar panel will be feeding the energy to the batteries through a charge controller, and by means of electronic speed controller will drive the motors which are connected to the rear wheels of the vehicle, and the motor and the car will move. It is how a solar car will work out. The last one is a building integrated photovoltaics, which is a revolutionary thing in the photovoltaic industry. So building integrated photovoltaics are defined as PV modules which can be integrated in the building envelope, into the roof or facade, or by replacing conventional building materials like tiles, etc. You can see this is a separate type of solar panels which can be installed or integrated into an existing building, into a roof. You can install it on the roof, or otherwise you can replace it with a facade. Facade means the front portion of a building where we use the mirrors. In place of a mirrors, we can use this building integrated photovoltaic panels, which acts both as a mirror as well as a photovoltaic panel. So the BIPV system is schematically illustrated in the following diagram, right? As can be seen from the figure, the PV system is integrated to the facade of the building. You can see to the front portion there is an indoor space, and to the front portion there is a glass mirror, and between the indoor and the glass mirror we have kept the solar module in between. So the outdoor air enters the system from bottom and leaves it from the top. So during this process it absorbs the heat of the PV modules. The air will absorb the heat of the PV modules, reduces their temperature, which results in an improvement in the efficiency and lifetime. This is similar to Trombe wall. So in between the room and the wall, or in place of a wall, here we will use a glass. We will keep a solar modules in between these two, and these glasses, initially we used to put glasses, right? Now in place of glasses we used to put building integrated photovoltaic system here. So this photovoltaic system will absorb the solar energy, and because of this they will generate the electricity. It's one thing. So because they are absorbing the solar electricity, they will get heated up and the performance will be reduced. So in between there will be some space, right? Through this space outdoor air will move up, and there is a vent provided outside it, and this air will take away all the heating in between the panel and the room, and thereby creating a cooling atmosphere between the room and the glazing, or a PI, building integrated photovoltaic system. So in that way the cool air will be circulated in between the BIPV and the indoor space, and in which case due to this the temperature effect of the solar panel can be normalized or can be nullified, or it can provide cooling to the solar panels, so the performance will be improved. So in some applications a fan and a duct is employed in the system in order to draw heated air into the room to reduce the heating load in winter. So in some applications it will be similarly, we can use it similar to that of a Trombe wall. So there are two purposes. There is a bottom vent and there is a upper vent. Now what it will do, there is a fan provided at the upper vent, and this fan will drive the heat air into the room during the winter season, and whenever sunlight falls on the glazing, it will produce the electricity, as well as whenever the sunlight falls on it, the space between the wall as well as the glazing will be heated up, and the air will be the hot air from the room will be drawn outside and will be circulated through, and the air will be heated up by the, and the cool air will be heated up by the solar energy, and as the air heats up, its density will reduce and it will move upwards, and the fan will be used to drive the heated air into the room, and thereby the room will get a space cooling effect. It's similar to a Trombe wall, but in place of a glass, we are integrated a solar BIPV system here, that is building integrated photovoltaic system here. Such a systems are called building integrated photovoltaic thermal system, BIPVT systems, and benefit from solar energy both electrically and thermally. Electrically you will get the electricity, and thermally you will get the space cooling, and this is how it will be functioning. It is the thing. In the next class or in the next video, let's go through the design of a PV system for your home, which is a last topic and very important topic in this particular unit, or very useful thing. Thank you.